Hi there, in this lesson you're going to learn about proportional and non-proportional relationships. First of all, to identify a proportional relationship, there are two quantities that are proportional if they have a constant ratio or unit rate. So, in other words, if you take all the ratios and simplify them, you should end up getting a constant ratio or unit rate. For relationships in which the ratio is not constant, so when you simplify the ratios, if they're not all the same, the two quantities are then non-proportional. For example, here it says complete the table to determine the cost for different numbers of pizzas ordered. So in this chart we have $8 for one pizza. How much would it cost for two pizzas? Well, 8 times 2 is 16. How much would it cost for three pizzas? Well, if each pizza costs $8, 8 times 3 gets you 24. How much would it cost for four pizzas? Well, 8 times 4 gets you 32. And how much does it cost for five pizzas? 8 times 5 gets you 40. Now, after we make our chart, we want to figure out our ratios. So it's just simple. Just take the top number, put it over the bottom. Top over the bottom. So our first ratio is 8 over 1. Second ratio is 16 to 2. Our third ratio is 24 to 3. Our fourth ratio is 32 to 4. And our fifth ratio is 40 to 5, right? So is there a proportional relationship? Are the ratios the same? Well, let's see. This is 8 over 1. This is 16 over 2. Can 16 over 2 be simplified to 8 over 1? Well, yeah, it can be. If you divide the top and the bottom by 2, you end up getting 8 over 1. What about 24 over 3? Yep, you can divide the top and the bottom by 3, and you get 8 over 1. Same thing with 32 over 4 and 40 over 5. They all end up simplifying down to 8 over 1. If you don't want to think about it like this, where you have to simplify the fractions, then just think of it like this. 8 divided by 1 is 8. 16 divided by 2 is 8. 24 divided by 3 is 8. 32 divided by 4 is 8. And 40 divided by 5 is 8. So they're all 8. They all have the same value. So, is there a proportional relationship? Yes. All of the ratios above are equivalent ratios. New vocabulary word, equivalent ratios. Because they all have the same value. The cost is proportional to the number of pizzas bought. Okay, here is another example. Here it says Andrew earns $18 per hour mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing? Explain. So first I'm going to start with my chart over here. I have it's $18 per hour. Okay, so my second part in this chart is going to be $36 in 2 hours, right? Because if he makes $18 in 1 hour, he makes $36 in 2 hours. Just do 18 times 2. In 3 hours, he would make $54, right? 18 times 3 is 54. And in 4 hours, he would make $72. 18 times 4 is 72. All right, so now let's figure out what our ratios would be. So, well, the 18 and 1 is simple. It'll just be 18 over 1. The 36 over 2 would be 36 over 2. And then it would just be 54 over 3 and 72 over 4. And now let's ask ourselves, are these ratios the same? Do they all lead to the same value? 18 divided by 1 is 18. 36 divided by 2, well, that's also 18. 54 divided by 3, yep, 18. And 72 divided by 4, yep, is 18. So all the ratios above are equivalent. They are all valued at 18. Therefore, yes, the amount of money he earns is proportional to the number of hours he spends mowing the lawn. Okay, and in our next example, we have Uptown Tickets charges $7 per baseball game ticket plus $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? Explain. So here I have the cost and the tickets ordered. So let's look at this. If he orders one ticket, It costs $7 for the ticket plus a $3 ordering fee or processing fee per order. So 7 plus 3 gets me $10. If he orders 2 tickets, it's 7 plus 7, right? $7 per ticket plus $3 for the ordering fee, so you get 17. Okay, for 3 tickets, it would be 7 plus 7 plus 7 because $7 is the cost of each ticket plus $3 order processing fee, which gets you 24. And then the last one, 4 tickets, would be 7 plus 7 plus 7 plus 7 plus 3 for the order fee, which gets you 31. So your ratios, you have 10 over 1, 17 over 2, 24 over 3, and 31 over 4. Are the ratios the same? Well, 10 divided by 1 is 10. 17 divided by 2, well, that doesn't equal 10. 24 divided by 3, that also doesn't equal 10. And 31 divided by 4 also doesn't equal 10. So no, they're not. They can't simplify down to the same value. They're not equivalent. Since they are not equivalent, the relationship is non-proportional. Okay, you can use the recipe shown to make fruit punch. Is the amount of sugar used proportional to the amount of mix used? Explain. So here's our recipe we're working with. To make fruit punch here, it says 1/2 cup of sugar, 1 envelope of mix, and 2 quarts of water. So for every 1 envelope of mix, we need 1/2 cup of sugar. So every 1 envelope of mix, 1/2 cup of sugar. So if I have 2 envelopes of mix, I would need 1 cup of sugar, right? I would just double this. For 3 envelopes of mix, I would need 1.5 cups of sugar. And for 4 envelopes of mix, if I just add a half to this, I would need 2 cups of sugar. So my ratios would be 1/2 over 1, or just 0.5 over 1, 1 over 2, 1 and 1/2 over 3, or 1.5 over 3, and 2 over 4. When you divide, are all the ratios the same? Well, let's look at this. 0.5 divided by 1 is 0.5. 1/2 is 0.5. 1.5 divided by 3, 0.5. 2 divided by 4 is 0.5. So yes, they all equal 0.5. Since the ratios are equivalent, the relationship is proportional. All right, and here are our concluding thoughts. First thing you want to do is make a table. Then you want to ask yourself, are the ratios equivalent? You divide the two numbers if you can't tell. If they are equivalent, then that means they have a constant ratio or unit rate. This means that they are proportional. And if they are not equivalent, then that means that they are non-proportional. All right, I hope you learned about proportional and non-proportional relationships. Thank you for watching.